So we've talked about properties of solids, liquids, and gases. And here's a summary. We're looking here at the three states of water: gas, liquid water, and ice. So in ice, well, let's start with liquid water. In liquid water, the particles are touchingly close, and they're free to move relative to each other. In a gas, the particles are very far apart. Because of those large distances, the intermolecular forces are pretty much non-existent. They are, it doesn't matter. In solid water, the particles now are fixed in position relative to each other. Ice is a crystalline solid, and so the molecules line up in a very particular pattern. They are still moving, but they're vibrating, right? The distance between these two things, the distance between the molecules affects the molar volume, affects the density. And here we have the temperatures. So water is a gas at 100 degrees or above. It's a solid at 0 or below. The big difference between solids and liquids is the freedom of movement of the particles. So in a liquid, the particles have enough freedom that they can move relative to each other, but the intermolecular forces are strong enough that they're also being held together. So, I kind of imagine this as being like people wearing Velcro suits, and you're kind of pushing through each other. And the Velcro is not strong enough to prevent you from moving, but it is causing you to stick together, right? In a solid, the Velcro would be so strong, or you are so weak, you don't have enough energy that you can't, you're trying, you're wiggling around, but you just can't break loose from the people around you because all your Velcro suits are stuck together. It kind of makes you feel claustrophobic even thinking about it, but that's... So we've got an indefinite shape for a liquid because the particles move. In a gas, we also have indefinite shape. In a solid, there's a definite shape, meaning that when you move a solid object from one container to another, it does not change shape. It retains its shape. Its shape is definite. Whereas a liquid or a gas will change its shape when it's moved to a different shaped container. The volume of liquids and solids is definite, meaning that doesn't change. The liquid will change shape, but its volume remains the same. So the arrangement of the people all Velcroed together is different. They can maybe spread out in a line now, but they're still stuck to each other. They're going to occupy the same volume. In the gas, there's no stickiness, and so they can just spread apart. And then these are the relative strengths of intermolecular force compared to the thermal energy. Because most things can exist as a gas, a liquid, or a solid, but it depends on the temperature. At a higher temperature, it's more likely to be a gas or a liquid because it has more thermal energy, more kinetic energy. Any questions? So liquids assume the shapes of their containers. Gases are compressible because there's all this empty space. So here's a cylinder with a gas in it, and we can push down on the plunger and push these together because there's space. There's no extra space in a liquid, and so you can't compress it. And that's good because otherwise your hydraulic brakes wouldn't work. When looking at solids, there's two broad categories of solids, crystalline and amorphous. Amorphous, the prefix a means without, and morph has to do with shape, so without shape. A crystalline solid has a regular ordered structure. There's a pattern in 3 dimensions of how the particles are put together. Amorphous solids, just a jumble, they're stuck together, like my son's sock drawer. When we look at changes between the states, we're all familiar with ice melting into liquid water and water evaporating into the gas state. So we can add heat to a solid and cause it to become a liquid. We can add heat to the liquid and cause it to become a gas. We can also cause it to become a gas by reducing the pressure above it. And then we can go the opposite way by cooling or increasing pressure and taking a liquid and cooling it. If you have a gas grill, you might have a propane cylinder like this to supply gas to the grill. LP gas is liquefied petroleum gas. It's mostly propane. So it's a liquid. It's liquefied because it's under pressure. Why do we want to sell it as a liquid instead of a gas? Because it takes up a lot less space. If you were to have this much gas in gas form, it would be huge, and nobody has space for that. So we can compress it and cause it to liquefy. What happens when you open the valve to your gas grill is we are releasing the pressure. In here there is some empty, well, not empty, there's some air space or gas space above the liquid, and some of the molecules here are in the gas state. When we open the valve, then some of them can escape. And as those escape, more of the propane molecules are going to evaporate to take their place up here.